Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afham bin Muazzam from the class AS2516D1, and today I'm going to make a video presentation about the subject PHY568, which is about electricity and magnetism. Here is the 4 subtopic that I'm going to cover for today's video presentation, which is the vector analysis, static electric field, static magnetic field, and also EMF transformer. The first one is the vector analysis. Vector is a quantity that has both magnitude and direction, and it is often used to represent quantities such as force, velocity, and displacement in physics and also engineering. In physics or engineering, writing represents as a letter with an arrow on top of it, such as A with an arrow and B with an arrow to represent the vector. This is the 3 formula that we can use to calculate the vector. The first one is the magnitude of vector, which represents how large the vector without direction in 2D or 3D. The second one is the direction of vector along the lines, and the last one is the distance of vector, which represents the vector between both two vectors in a triangle shape. In vector, we can also add or subtract the vector to get a new vector. They are also a product of vector which comprise of dot product and cross product. For dot product, it is a scalar vector which the vector A and B, which represents in the picture above, A and B is perpendicular. For a cross product, the theta is equal to 0 because A and B is parallel with each other. This is an orthogonal coordinate system which have the 3 states of vector, which is in Cartesian, cylindrical, and also spherical. In Cartesian, we have the vector of x, y, and z. For cylindrical, we have r, phi, and z, and also spherical, we have r, theta, and also phi. In these slides, we can see the 3 states that I have mentioned in previous slide, which is the Cartesian, cylindrical, and also spherical. In this formula, we can see that we can calculate the differential length, area, and also volume of the 3 states that I have mentioned. The next slide is the del operator, which represents operation like gradient, divergence, and also curl, which describe how a field changes in space. For a gradient, it is applied to calculate a scalar field, divergence applied to calculate a vector field, and also curl applied to calculate a vector field which measures rotation on the field. This is the required formula that we can use in those 3 states, which is the Cartesian, cylindrical, and also spherical coordinates. For the static electric field, we have encountered the Coulomb's law. Coulomb's law is the force of attraction or the repulsion between 2 charged objects, mentioning as Q1 and Q2. The Q represents the charge, and along the line connecting both charges and directly proportional to the product of Q1 and Q2 of the charge, and the product of Q1 and Q2 is inversely proportional to the square of the distance. We can see over here that the final formula is the F equal to K, the product of Q1, Q2 over R squared, and the K is the constant. Next is the law of electric charges. The electric force is the attraction or repulsion between 2 charged objects. Like charges of the same sign repel each other, while unlike charges attract them. The distance between the charged bodies Q1 and Q2 must be large compared with the linear dimensions of the bodies, and Q1 and Q2 must be a point charges. The sign of Q1 and Q2 must be taken into account. This is the vector form of Coulomb's law. We can see a bunch of formula over here, and to get the final formula, we have to include the formula number 2 and 3 into the first formula, and we get the final formula of the vector form of Coulomb's law. Next is the Biot-Savart's law. The Biot-Savart's law states that the differential magnetic field intensity produced at a point P by the differential current element is proportional to the product of the current element, the differential length, and the sign of angle between the element at the point P. It is inversely proportional to the square of the distance between the point and the element. Determining the direction of magnetic field, we are considering using the right-hand rule. The direction of DH can be determined using the right-hand rule, where the point of the thumb is the current and the curved fingers is the direction of the magnetic field DH. This is the vector formula in determining the Biot-Savart's law in a line. We can see over here that there are 3 vector formula that we can use to determine the charge current in 3 stages, which is the line current, the surface current, and also the volume current. Next one is the EMF transformer. The EMF stands for the electromotive force, which is the energy provided by a cell or battery per coulomb of charge passing through it. It is equal to the potential difference across the terminal of the cell when no current is flowing. These are the 3 states of the EMF varied by a 3 states, which is the first one is a EMF varying in a loop in a static B field, which is called the motional EMF. The second one is by having a stationary loop in a time-varying B field, which is called the transformer EMF, and also by having a time-varying loop area in a time-varying B field. Maxwell equations. The Maxwell equations are a set of 4 fundamental laws that describe the behavior of electric and magnetic fields and their interaction with charges and current. These equations also describe how electric and magnetic fields propagates as a wave. In the Maxwell equation, the 4 fundamental laws are the Ampere's law, Faraday's law, Gauss's law, and also non-existence of monopole. That is all from me. Thank you very much for listening to my video.